this statement can be improved. That is, in the complex number system, every nth degree polynomial function has precisely n zeros. Now, some of those zeros might be called real. You may hear some of them say rational, some rational, imaginary numbers, whatever. You're not gonna for the most part, you're not gonna see imaginary numbers on a graph, but you can see the real zeros on a graph. All right, that result is called the fundamental theorem of algebra. Maybe you've heard of this fundamental theorem of algebra. All it's saying is, in the complex number system, every nth degree polynomial has n zeros. All right, so for example, A, the first degree polynomial f of x equals x minus 2. This is a random question. How do I know that's a first degree polynomial? For A, how do
The degree is 1.
It is a one.
the degree is 1 because x is like to the first power. We know that. Okay, that's the degree. So that's why they call it a first degree polynomial. It has exactly 1 0. X equals 2. How did they get the 0? How do we find zeros? Another random question.
You set it to 0, and then you
Yes,
would do plus 2 on both sides.
yes, great. You set the function to 0 and you solve for x. Very nice. Let's look at B. Counting multiplicity, the second degree polynomial function, f of x equals x squared minus 6x plus 9, can be factored as x minus 3 times x minus 3. It says it has exactly 2 zeros. Notice that the degree is 2. They call it a repeated 0 because it's the same 0, right? It's 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 called a repeated 0. They're not distinct zeros, but you did get that factor twice. What's another way you could have written x minus 3 times x minus 3 in a concise format?
X minus 3 squared.
Very nice. X minus 3 squared. Now, if I ask you, what is the multiplicity? What would you say? Do y'all remember multiplicity from some sections ago? Someone other than the carrier. What is the multiplicity of this?
Even.
It's even because K is what?
2.
2. K is 2. So the multiplicity you get from the number on the outside of the parenthesis, not on the inside of a parenthesis, on the outside. All right. So the multiplicity is 2 because we know it's an even multiplicity. What does that tell us about the 0 x equals 3? What happens at x
It's
equals
going to
3?
touch it.
It's going to touch or bounce, as I like to say. It bounces off of the x-axis. It does not cross the x-axis. So very good. So your problem looks something like this. Now, what's the shape of this function?
Quadratic.
Quadratic. So what do we call
B.
the shape? It's like a what?
U shape.
U
Oh,
shape,
you.
right? So we're gonna be, so this is your 0 right here, or your x-intercept, 3, 0. So it's gonna, and y'all know this because y'all know transformations, right? You know that it's gonna be a horizontal translation to the right. So that's why you see that it doesn't cross the x-axis, it bounces off the x-axis. Let's look at C, the third degree polynomial function. So notice, what did they do first? They factor it out in x, right? Factor out in x. But notice when they factor out in x, they have x squared plus 4. Let me write that out. X squared plus 4. If we set that to 0, let's go back through this. How will we solve for x? We went over this briefly last time, but let's go over it again. How would you solve for x?
Yeah, I had the square root, but you
Not
subtract
yet.
You'll subtract 4 from this
Subtract
side.
4. Yep, let's do that first and then do it.
Square
square
root
root.
both sides.
Square root both sides. And anytime you do the square root of something squared, you have to, don't forget to put what in front of that radical.
Plus and minus.
Yeah, let's do plus or minus. Then we have the square root of -4, which can be broken down as what? What two factors?
Negative
Negative
1
4.
and 4.
Yep. And we know that the square root of -1 is what?
I.
Yep. So x equals plus or minus I, and the square root of 4 is
2.
2.
2. So we know that the zeros are 0, because if we set x to 0, it'll be x equals 0. And then we can also write these zeros as factors by doing this: x minus 2i and x plus 2i. All right, so you can kind of work it out and then um, form it into a factor. All right, let's look at D. If you had to guess, how many zeros do you think it would have? D.
3.
3. All right, 3 zeros. How do you know that, Nakir? Just in case someone missed it.
Because the degree is to the
The
third
degree
power.
is to the third power. All right. So normally, why can't we set this function to 0 right now and use our previous methods to find the zeros?
Because the degree is 3.
It's 3. Okay. Normally when we have to the second power, let's go over what we used to do. When we was to the second power, we used to do what and what, or what again?
We would
If it was to
factor.
the second factor, or if it was to
Use
the second power. Someone other than the
the
Curie answering all of them. If we had a function and it was the second degree function, and we were trying to find the zeros, we would set the function to 0. We could factor it. If it's not factorable, we do what?
use the
Quadratic.
quadratic formula.
Quadratic formula.
Quadratic.
Quadratic formula. Quadratic. Because every time it's not going to always be factorable. A quadratic equation may not be factorable, so you have to use another method, like the quadratic formula. Now for D, it's cubed, so we got to come up with a whole nother method to figure out what the zeros are. So that's why someone came up with something called the rational zero test. If the polynomial has integer coefficients, every rational zero of that function has to form rational zero equals P over Q, where P and Q have no common factors other than 1, and P equals a factor of the constant term, and Q is a factor of the leading coefficient. I'm about to explain that because I know that didn't make any sense. All right, so we're going to use the rational zero test to find the possible rational zeros of that function we just talked about. All right, we're going to do something called P over Q. It's the rational zero test. All right, now, can someone just read to me? What does P equal?
A factor of the constant term.
Thank you. It's a factor of the constant term. Now, let's look at our function. What is the constant of this function?
1.
The constant. The constant.
Negative Oh, it's
6.
6.
Negative
-6.
6.
-6. -6. All right. Now that we know that, we're going to write out all of the factors of 6 and -6. It doesn't matter. We're going to write it like this: plus or minus. Give me the first factor. Let's do it in order.
1.
What's the first factor of 6?
1.
1. What else? What else we got?
2,
2,
2. Yep. Plus or minus
3.
3,
3 and plus or
6.
minus 6. All
6.
right. All right. Let's see what Q is all about. Q, somebody else other than Kenneth. Just read to me. What is Q? What does it equal to?
A factor of the leading coefficient.
Correct. That's your leading coefficient. So for our function here, what is our leading coefficient?
1.
1. Correct. 1 is understood to be right there in front of x cubed. So that's not too bad. It's just plus or minus 1. All right. Now we have to divide each p by each q. This one is kind of easy because there is only one q. So this one is not bad. So if I divide 1, 2, 3, 6 by 1, then we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Let me point this out. There is no plus minus symbol in Weber sign. I don't know if y'all got caught that yet, but there is no plus or minus symbol in Weber sign. Therefore,
You got to split it up.
you got to split it up. So how many, these are the possible rational zeros right here. How many do we have in all? Trick question, trick question. How many do we
8.
have in all?
8.
8. Yes, because it's positive 1, it's negative 1. It's positive 2, it's negative 2. Don't put a plus in front of the numbers, you guys, when you put it in Weber sign. Just put 1. Then negative 1, 1. Negative 2, 2, for example. So this is the answer for this. I'm not going to write it back up. This is called the possible rational. These are the possible rational zeros. Here's what it means. Three of these are, let me say it like this. We know that it's definitely a possibility that some zeros are in this list, all right, that correspond to this function. Now, question, how can we test out, I'm gonna hide this. How can we test, I got 3 different ways I want you to think of. How can we test to see if, I don't know, if we choose 1 or 2 or whatever, how can we test to see if it's a zero of this function?
Well, at the bottom it say use synthetic division.
Man, Nakira, you ain't had to point that out. I was trying to hide that, Nakira. Oh, okay. Nakira said, look, right here it said use synthetic division. All right, so that's one way, but I got you in the next. See, 2 more ways, so I didn't write that down. All right, so synthetic division. Okay, let me ask you this question about synthetic division. If we use one of these possibilities we just wrote down and we plug into synthetic division and we get done, how do we know it's a zero?
because
How
you
do
The
would
we
have
know?
It
a,
should equal 0 on the end.
What, okay, what do we call that on the end?
The
The
remainder.
remainder.
Remainder. The remainder will equal 0. That's how we can tell if that k that we put in that little box is a 0. If it does not equal 0, the remainder that is not a 0. As simple as that. Anybody know of another way we could figure out, we could test to see if something is a 0 or not?
long
Maybe.
Could
division.
you substitute it in?
Okay, I'm gonna put long division over here then. Long division. Oh, substitute it in. Exactly. What do we call that under somebody else? When we substitute it in, we use this word. Don't say it, Nakira. It starts with an E. What are we doing? Starts with an E.
Evaluate.
Evaluate. All right, we can evaluate the function. All right, someone other than Alicia and Nakira. All right. Give me one more way we could possibly figure out if a number is a zero of a function. One more way possible. Anybody other than Akira and
You
Alicia?
can set it to 0. I'm sorry.
Well, if we set it to 0, that's what we were saying earlier. Let's say we set this to 0 right here. Where was it? If we set x cubed minus 7x minus 6 equals 0, where can we go from there? You see what I mean? It's not a quadratic. We can't
Oh,
just
true.
add 6. That's not going to help us, right?
Mhm.
So that's why we came up with this rational zero test. But we have a possible list right here of what the zeros could be. But how can we test? How can we come up? What's another method that we can look at that could possibly tell us it is a zero? Anybody?
The
Could you
quadratic
could you
formula.
like
Everywhere you see X, you'll plug in a number. I don't know.
That's evaluating the function. That's the same thing, right? Evaluate the function means what Nakira said, substitution. Nakira, you remember, I think Nakira was the one who said sub it. Just sub it, okay? Um, Anybody, before I give the answer out. What did you say, Nakira?
I was trying to say use the T chart, but that is the same way as evaluating the function.
Yeah, that's the evaluating function. All right. Anybody else want to guess before I
Hey, C
reveal?
Mac.
We can't because it's a quadratic. I mean,
Oh
it's
yeah.
not a quadratic. I mean, it's not a quadratic. All right. You could graph it, you guys. How would you know from a graph? You can put it in Desmos. How would you know if you plug in the Desmos what it if it is a zero or not? How would you know from a graph?
How many times it touches the x-axis? I mean, not how many
Not how
times,
many times,
but like at what point it
Point.
crosses the x-axis.
where it crosses the x-axis. It's called the x-intercept. That's a zero. X-intercepts and zeros are the same. All right. I'm going to show you the hard way of doing it. We're going to do, well, I'm going to write this down first. Graph the function to determine x-intercepts. Okay. We're going to work on the first method, synthetic division, today. And then we're going to do a little bit of graphing too when it gets really hard. All right. Now, synthetic division. We have 8 possibilities. Let's guess at what we think will work. What number out of the 8 possibilities that we have right here, what number do you want to try? It doesn't have to work. We're just trying it.
6.
All
6.
right.
Yeah.
All right. Let's try 6 in our little box over here. Be careful. What should go up here?
1,
1, 0,
no,
Oh, okay.
yeah.
0. Okay.
-7 and 6,
-7 and
-6.
-6. Let's try it. And I might erase, so y'all might have to put this on because we don't know if it works. We'll see. All right. Bring that down. 1. What's the next number we're going to put up here?
6,
What's the next number we're going to put up here?
6,
What's the next number?
36,
What's the next number?
43. No. 29.
Y'all see it's not going, so it's already getting real big. We already know it's not going to work out. But let's keep on going. 29 times 6.
174,
Ooh. And then
168,
all right, so we did not get 0 for our remainder. So we know that 6 is not a 0. Does everybody understand that 6 is not the solution? All right, just yet. All right. So I'm gonna erase this. Somebody else give me another possibility. We're gonna test it out.
3.
3. All right, let's try 3. 1, 0, -7, -6. All right. Other than Alicia, Kenneth, and Nakiria, y'all tell me what number I should write down first. Other than Alicia, Kenneth, and Nakiria. 1. Thank you, Tanaya. Next number.
3.
3. Next number.
3.
3. All right. Someone other than Tanaya, Raven, Monisha, Kenneth, Nakiria, and Alicia. What's the next number? Someone other than Monisha, Nakiria, Tanaya, Raven, Alicia. Come on, y'all. Y'all know I don't like calling y'all out. So just volunteer. Alicia, what did you say?
I said 9.
You don't supposed to be saying anything. Okay. 9. All right.
Then 2, then 6.
All right. 2. Oh, okay. Sweet. And then,
0.
0.
okay, that worked out. So we know what is a 0 right now.
3.
3.
3. All right. So here's what we have so far. Write this down. F of x equals, how do we write 3 as a factor?
X plus 3.
3, right here. How do we write that as a factor?
Oh, x minus 3.
X minus 3. Remember, you got to set it to 0.
95.
All right. Now, we just learned that from our synthetic division right here, that 3 is a 0. And what other factor is times x minus 3 will give us x cubed minus 7x minus 6?
X squared plus 3 plus 2.
All right, hold on. Be careful. You said
X
x
squared.
squared plus.
X squared plus 3x plus 2.
All right, good. Can we break down x squared plus 3x plus 2?
Yes.
Is it factorable? All right. We're going to write it as linear factors. This is called the complete factorization. All right, complete factorization. What are the factors for x squared plus 3x plus 2?
X plus 1,
X
x
plus 1 plus 2.
Very good. So this is good. Now we know what our actual zeros are. Our actual zeros are what? What are the zeros?
3, -1, -2.
Very nice. Notice we have how many again? We said we were have 3, and we ended up with 3. All right. Any questions about that? Any questions? And we use the rational zero test to determine the possible rational zeros, but we had to test them to see what really are the zeros. Not all of those are zeros, right? Because there are only 3. All right, let's look at this. I wanted to give you a hard one because I want you to see that it's not always easy to find P over Q. All right, let's go with this next situation where P, let's read P again. According to our first page of notes. What is P again?
A factor of the
Constant.
constant term.
A factor of the constant term. So what is our constant this time?
40.
40. So here's what I'm going to do. I'm going to do a little shortcut way because I don't want to write plus or minus 1,000 times. So I'm going to do this. I'm going to pull up parentheses here. This is my little shortcut. All right. Let's write out the factors of 40. So 1, that's my contribution. What's your contribution?
2,
2, what else?
4,
4,
All right.
5,
Yep.
8,
8,
Mm-hmm.
10,
10,
Mm-hmm.
40.
What else?
No,
20.
20.
20, 20, 20, 40. All right. Let's look at Q. Q. Let's go back to the first page. Q equals what?
a factor of the leading coefficient.
Yep. Factor of the leading coefficient. What is the leading coefficient? Someone other than Kenna, Nakiria, and Alicia.
12.
12 is correct. Plus or minus. Let's figure out what are the factors of 12. 1, that's my contribution. What's next, y'all?
2,
2,
2,
2,
3,
3,
3.
4,
4,
6, 4, yeah.
Yep. And
And,
12.
12.
12.
well, all right, we're not done. Guess what? This is where it gets really crazy. We got to divide each P by each Q. All right, but here's what we're going to make sure we do not repeat the same possible zero. All right, so if it's already in our list, we do not repeat that zero. All right, let's look at it. So the first thing I'm going to do is divide 1 by 1. What do we get?
1,
1,
1,
1. So I'm going to write plus or minus 1. All right. Next, I'm going to divide 1 by 2. What do we get?
1 half, or half.
Yeah, 1/2. Y'all see where this is going. 1 divided by 3.
1/3,
1/3. 1 divided by 4.
4,
1 4,
1/4,
1/4. 1 divided by 6.
6,
1 6,
1 divided by 12.
1,
1
Mm-hmm. We're finished with the ones. Does everybody see that? Any questions so far? We're not done because we got to go all the way to 40.
oh my Jesus.
You should have told us we need a scratch paper.
Yeah, you need. I need more room. I need to update these notes and put more room in here because this is not enough. Y'all see, I'm going all the way up on top of possible rational zeros right now. All right, let's start. Let's go with 2. Let's start with our P equals 2. All right. What we're gonna do first is divide 2 by 1. What do we get?
2,
2,
All right, good. 2 divided by 2.
1,
1,
But isn't it already in the list?
yes,
yes,
So do not write it. All right. 2 divided by 3.
2/3,
Yep. 2 divided by 4.
1,
1 half,
1/2,
Already in the list. Not write it. 2 divided by 6.
1/3,
1/3.
Do we have it already?
yes,
Yes.
Yep. 2 divided by 12.
1
1
6.
6,
1/6. We have it already. Don't write it. All right. Let's move on to 4. 4 divided by 1.
4,
Yep. 4 divided by 2.
2,
We already got it. So don't repeat it. 4 divided by 3.
4/3,
4 divided by 4.
1,
We already have it. 4 divided by 6.
2/3.
2/3. We already have it. 4 divided by 12.
1/3.
We already have it. Good. Now we're moving on to what number?
5.
5,
5. All right. 5 divided by 1.
5,
Yep. 5 divided by 2.
5 over
5.
2.
Yep. 5 divided by 3.
5
5
thirds.
over 3.
Yep. 5 divided by 4.
5 over 4.
5 4.
Yep. 5 divided by 6.
5 over 6.
6.
5 divided by 12.
5 over 12.
Yes. Let's go to 8. 8 divided by 1.
8.
8 divided by 2.
4.
We already have it. 8 divided by 3.
8 over 3.
Yep. 8 divided by 4.
2.
2. We already have it. 8 divided by 6.
8 over 6.
Which
4
is
thirds.
4 thirds. We already have it. 8 divided by 12.
2 thirds.
2 thirds. We already have it. All right. We're moving on to what number now?
10.
10.
10. 10 divided by 1.
10.
10 divided by 2.
5.
5.
We already got it. 10 divided by 3.
10 over 3.
All right. 10 divided by 4.
5 over 2.
5 over 2. We already got it. 10 divided by 6.
5 thirds.
We already
We
got
already got
that
it.
one.
Third.
Yep. 10 divided by 12.
5 6.
5, 6. We already got it. We're moving on to what P now?
20.
20.
20 divided by 1.
20.
20 divided by 2.
10.
We already got 10. 20 divided by 3.
20 over 3.
20 divided by 4.
5.
We already got 5. 20 divided by 6.
10 thirds.
10 thirds. We already got it. 20 divided by 12.
5 thirds.
5 thirds. We got it. We got it already. Finally, 40. 40 divided by 1.
40.
40.
40 divided by 2.
20.
20.
We already got it. 40
20.
divided by 3.
40 over 3.
40 over 3. 40 divided by 4.
10.
10.
10. We got it. 40 divided by 6.
20 over 3.
20 over 3. We already got it. 40 divided by 12.
10 thirds.
10 thirds. We already got that. Whew, we are done with the list of possible zeros. All right, I want you to tell me, I'm giving you a minute. How many possibilities are there in all?
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50.
Ooh, is it that many? Okay. Is it really 50, y'all?
11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24. Is it 48? Let me
48.
recount.
It might be 48. It might be 48. But
That's
still,
right.
that's
48.
a lot. That's a lot. Still a lot. Now, this is a situation where I would. Now, do you really want to just guess at what numbers would work in synthetic division? No, because there are 48. What's
Our
the
whole
helper?
test will be over.
What did you say?
I said our whole test will be over.
That one problem would be the test.
Right. then and then it's gonna take me forever to figure out did you write all your possible rest of zeros down. So now, so we're gonna use something else to help us. What y'all think we're gonna use? What y'all
Graph.
think we're gonna use? Graphing. All right. So what I want you to do is I want you to go to Desmos, and I want you to put this function in right here. All right. I'm gonna put this function in and see what it tells us. All right. So I'm gonna go to it while you all going to it. So that's why I did it extreme. I did an easy one, and I gave you an extreme one to show you. It got to be an easier way. And the easier way is why not graph it and analyze the graph.
Ooh.
Now, what we're looking for when you actually put it in Desmos, what you're looking for is where is it going to cross something that we recognize. All right, that's a nice whole number. So let me stop sharing this so I can share my Desmos.
Okay, it tell you.
You just gotta touch it, right? Touch it where it crosses the x-axis. All right. Based on what you all see on the screen, what do you think we can possibly use as a zero that looks like it's directly on that number?
4.
4.
4, definitely. This number right here, right? Because the other ones are decimals. Y'all see that, right? So definitely 40. So that's what we're gonna the graph is going to assist us, all right, with coming up with the other ones. So what we're gonna do, I'm gonna go to the whiteboard now. We're gonna use synthetic division, but we're gonna use 4 as our K. So let me stop sharing. Let's use 4. All right, what other number should we put up there in that row for this function?
12.
12.
Negative
Negative
41.
41. Negative
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 38
38.
and
and
40.
4.
All right, very good. All right, 12. What's the next number?
48.
48. Next.
7.
Next.
28.
Next.
10.
Negative 10.
Negative 10.
Yep. Next.
Negative
Negative
4.
And
0.
all right. How do we know again? Notice redundant. How do we know that 4 is really a 0? I know we looked at the graph, but this confirms that 4 is a 0. How do we
But
know
the
that?
remainder is 0.
The remainder is 0. All right. Very good. So here's what we have so far. We started off with P of X equals 12x cubed. Y'all might have to write all this on the back of your notes. 41x squared minus 38x plus 40. Now we also know one of the factors. How do we write 4 as a factor?
4.
X minus
X.
X minus 4. All right. We know that x minus 4 times something will give us the original function. How do we write this part right here?
12x
12
squared
x squared.
plus 7x minus 10.
All right. So now we just have to work on this. It's a quadratic, right? So we can figure out what that is. How do we figure out the factors of 12x squared plus 7x minus 10? Someone
AC.
other than, okay, AC method. All right, I'm going to give you a whole minute to start on the AC method. I'm hoping that you're not looking, don't stop and do nothing. I want you to start on it. All right, AC method. I give you 60 seconds. All right, what's the first step in AC method? What would you do first?
12 times -10.
12 times negative 10 is?
Negative
Negative
120.
120.
All right, let's figure out the factors of 120. 1 and 120, what else?
12 and 10.
2 and
Negative 8
2 and
and
6.
2,
15.
2 and 60, 3 and 40, 5 and, you just got to get that calculator out. 5 and
24,
24, 6 and
20,
8 and,
15,
what is it?
15,
15, 10 and,
12.
all right. What do y'all think will work? All right. What are we trying to see? We trying to
8 and
multiply
15.
factors. Very nice. How so? 8 and 15. Be specific.
15 minus 8 is 7.
You said 15 minus 8. So it'd be negative 8. That's what you're
Negative
saying?
8 plus
Negative 8?
15.
Yes,
All
ma'am.
right. All right. So now what we're going to do is we're going to rewrite it. Our 12x squared. And then we're going to put minus 8x plus 15x minus 10. And we're going to group. What would you take out of the first group?
2.
4.
No.
4.
4.
4 what?
4x.
X.
4x times what is 12x squared minus 8x?
3.
3x minus
X minus 2.
2. All right. Plus, what about 15x minus 10?
You would take out
5.
5.
5. Then we get our 3x minus 2 that we wanted. So the factors are 3x minus 2 times 4x plus 5, or 4x plus 5 times 3x minus 2. All right, so I'm going to go over here to the left. Our factors are x minus 4 times 3x minus 2 times 4x plus 5. This is called, again, the complete factorization. All right, the complete factorization. From here, we can figure out what the actual zeros are. All right, what are the zeros? The zeros are what?
Positive 4.
4.
4. All right, so that came from that
2/3.
one. All right, 2/3 comes from that one.
Minus 4.
Negative 5 over 4 comes from that one. Very good. Again, to find your zeros, all you do is set the function to 0. And here, in this case, since we factored it, set all your factors to 0 and solve for x. All right, so these are called the actual zeros. There were 48 possibilities, but of course, since our degree was 3, we were only looking for the correct 3 zeros, all right, even though there were 48 possibilities. All right, very good. We're going to move on and practice another problem. We're going to skip to the next page. where it says example 1A. So let me stop sharing this and go to our notes again. All right, example 1A. Find the possible rational zeros of f of x equals x cubed minus 5x squared plus 2x plus 8. So we're going to practice P over Q again. What does P represent again?
Factors of a
Factors of
constant.
the constant.
Exactly. What is our constant for this function?
8.
8. All right. What are the factors of 8?
2.
1, 2,
1, 2,
4,
4, and 8.
8.
All right. What does Q represent?
Factors of the leading coefficient.
Yep, which is?
1.
All right. Not too bad when Q is only 1. So our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So I know these questions I ask over and over again, but how many possible rational zeros are there? Possible rational zeros.
8.
8. 8, because there's a negative and a positive version of each of these numbers. How many zeros are there actually, though?
3.
3.
3.
3, because the degree is 3. Very good. Let's find those actual rational zeros. All right. What would you do for the next part? Find the rational zeros. What would you do now that you know what you know?
Synthetic division.
All right, synthetic division. And what else could possibly assist us with our synthetic division?
Graphing.
Graphic.
Graph it. All right. I want you to graph the function. And then I just want you to come up with one zero that you are pretty sure works from the graph. So I'm gonna let you do that. I'm not gonna do it. I want you to practice using decimals. You tell me what would be a good number to plug in synthetic division.
Four.
4. All right, 4 again. Okay, let's see. We got 1. Other than the carrier. Somebody other than the carrier. What's the next number we're gonna write
4.
down? 4. All right. Other than Nikiria and Alicia, what's the next number we're gonna put down? All right. Other than Alicia and Nikiria, what are you gonna put? What's the next number?
-1.
-1. All right. Other than Kenneth, Alicia, and Nikiria, what's the next number?
-4.
-4. Was that you, Monisha?
Yes, ma'am.
-4. What's the next number? Someone else.
-2.
-2. All right. Other than Monisha, Nakiria, Alicia, and Kenan, what's the next number? All right. Other than Alicia, Kenan, Monisha, Nakiria.
Is it
All right, Raven, you muted too fast. What'd you say?
-8?
-8. I think Tanaya did that too earlier. I heard shoot, and that's all I heard because y'all mute too fast. All right. -8, and then Last number. Somebody else.
0.
0. All right. So we confirmed that 4 is right. Now, what we have so far is f of x equals. All right, we got this part. What do we know so far? Give me some factors. What do we know so far?
X minus
X
4.
minus 4.
Very good. We know x minus 4 is a factor. And from synthetic division, what did we glean from that part? The
X
other
squared
1
factor
x
is,
squared
minus X
minus
minus 2.
okay, very nice. All right, that's a quadratic. So is it factorable?
Yes.
Yes.
All right, great. What are the factors?
+1 -1.
Plus, wait a minute, gotta be factors of that number, right?
Oh, it's 8. Okay, my bad.
This number here, gotta be factors of this number.
X plus 2, X minus 1.
X plus 2. Would that give us
x
the
minus 2,
negative
x plus
one?
1.
X minus 2, X plus 1. All right. Now, let me ask you this question. If it wasn't factorable, how would you have gotten the zeros? How would you have computed the zeros if you could not factor?
You just
Quadratic
grab it.
formula.
Quadratic formula. Very good. Or that, or if it's an imaginary number, y'all kind of know how to do that too. If it was like x squared plus 4, you would just subtract 4 like we did earlier. All right, great. This is called the what again? The complete factorization.
Factorization.
Yeah. Or they may say something about linear factors or something like that. Product of linear factors. All right. So what are the actual zeros?
4,
4,
negative
2,
1.
and -1.
Very nice. 4, 2, and -1. All right. If we sketched it really quickly, 1, 2, 3, 4, we know it's going to be something there, something there, something there. What's the end behavior of this function? Tell me what's going on the right side.
It's rising.
Mm-hmm. On the left side,
It's falling.
and all of these, what's the multiplicity of these here, these zeros here? So what's the multiplicity?
Odd.
Odd. All of them are to the first power right here. So that's how I know it's going to cross through these zeros, okay? It's going to cross. All right. Let's try one more for the road. Find the possible rational zeros. So what I want you to do, I'm going to give you 2 minutes to find the possible rational zeros. All right, starting now. All right, let's see if you are right. So P would be the factors of the constant. What is the constant term here?
3.
3.
3. So did you put plus or minus 1 and plus or minus 3 for the top part?
Yes.
All right.
Yes, ma'am.
For Q, plus or minus what?
1 and 2.
1 and 2, because we're looking for factors of the leading coefficient, which is 2. But we're not done. You have to divide each P by each Q. Let's start with 1. 1 divided by 1 is?
1.
1.
What about 1 divided by 2?
1/2.
Yeah. Then let's go to 3. 3 divided by 1.
3
3.
over
3.
1.
And then 3 divided by 2.
3/2.
Yep. So how many possible rational zeros are there?
8.
8 possible rational zeros, but we know there are really only 3. All right. So let's actually find the zeros that actually work. It would be best to do what at this point?
Synthetic.
Synthetic with the assistance of
Desmos.
Desmos. All right. What I'm gonna so I want you to graph it, and I want you to determine what number we will probably definitely work for this.
-3.
-3. All right, let's see. 2. What's the next number we're gonna put up on our synthetic division?
-6.
-6. Next.
-3.
Next.
9.
Yep. Next.
9.
Mm-hmm.
1.
1. Very good.
-3.
3.
Yep. It
-3.
works
0.
out. It works out. So far, let's see. Let's write what we have so far. We have f of x equals. Tell me one factor that we have so far.
X plus 3.
X plus 3 times what other factor will give us 2x cubed plus 3x squared minus 8x plus 3?
2x squared minus 3x plus 1.
Very nice. Now that's a quadratic. Possibly we can factor it. Is it factorable?
No.
All right. AC method, which will mean that we'll multiply 2 times 1, right? Which gives us 2. Are there factors that will give us -3? Yeah, right? Negative,
Yeah,
negative,
yeah. X
right?
minus 1.
-1 plus a -2. All right. So let's write it out. We have 2x squared, and then we have, you can write -1x or -2x plus 1. All right. You could take out an x, that's 2x minus 1. And you could take out a -1, which will give you 2x minus 1. All right, I'm going to look back at it. 2x squared minus 2x minus 1x. That works out. So we know the factors are x plus 3 times 2x minus 1 times x minus 1. If I ask you, what are the zeros? You would say what?
-3.
-3. Positive
Mhm.
1.
And
1/2.
1/2. All right, again, you're just setting these factors to 0 and solving for x. All right, let's sketch it really quickly before we go. We have -3, 1, and 1/2. That's going to be kind of close right here. Okay. So we know the end behavior. You kind of already discussed it with the other. We know it's going to cross. How do we know that? Because the multiplicity, all of the factors have a multiplicity of 1 or odd multiplicity.